We're going to continue in this objective to work with absolute values, but we're going to look at absolute value inequalities. We're going to look at them in this lesson and in the next one. Everyone in this lesson, it has to do with absolute values using less than. Okay, so all of these are going to be less than. All right, so the form of our inequalities will be the absolute value of x, and that could represent anything in terms of x, less than a number. So, for example, if we had the absolute value of x is less than 2. What that means is x represents any quantity whose absolute value would be a number smaller than 2. And for example, let's just see if we can name some of the answers. The answers are infinite. Sorry about the dog coughing in the background. He's got a cough today. Numbers that have an absolute value that's less than 2. This is not the answer. This is a list of some numbers that would be answers. X could be 1 because the absolute value of 1 is less than 2. X could be 1.5 because the absolute value of 1.5 is 1.5, and that's smaller than 2. X could be negative 1.75 because the absolute value of negative 1.75 is 1.75, but that's less than 2. X could be 0. What we're talking about on a number line, if this is 2 and this is negative 2, then if x is any number in between there and you take its absolute value, it will be less than 2. The positive numbers have absolute values less than 2. The negative numbers have absolute values less than 2, as long as the numbers are between negative 2 and 2. A way to say that is the following. If the absolute value of any expression in terms of x is less than some constant number that I'm going to call a, then on a number line, x will be between negative a and positive a. It will be between them. Another way to write that as an inequality would be negative a will be less than x, which will be less than a. I call this the between notation because x is between these two. As an interval, when there is no equal, it is negative a to a because intervals are always from left to right. Hopefully you remember from a previous math class that if this is strictly a less than, there's no equal with it, then you use parentheses. If instead, if you had the absolute value of x is less than or equal to a, then on the number line, where I have negative a and a, it will have a bracket, and it will be everything between them. And I didn't say this up here, I should have. This will be a parentheses, just like it is parentheses in the interval. Okay, so this interval will be from negative a to a, and it uses the brackets because a is a solution. And as an inequality, it will be negative a is less than or equal to x, which is less than or equal to a. So this whole lesson is hoping that you remember some things about intervals from Math 307 or from Mod, I think it's Mod 4, maybe Unit 2. So you might want to go back and look at your notes from a previous course. I'll talk about them as I do each of the example problems. All right, problem number 1. It says solve the inequality, then graph the solution set. Okay, well, the inequality is absolute value of x is less than or equal to 7. When it is a less than inequality, take this positive number, do the negative, a less than or equal to, which is the same sign you have there, the x from the absolute value, another less than or equal to, and the positive. So in words, what I'm going to say is it is between the negative and the positive of the constant. It is between the negative and the positive of the constant. So this is my solution. It wants the solution, though. This is an inequality. It says the solution is, type your answer, simplify your answer, type it in interval notation. Okay, interval notation. Well, I like to do all three. Inequality. On a number line, it's going to be between -7 and +7. So it's going to be between them. You would use a bracket because equal is part of it. Then finally, as an interval, it looks just like the number line, -7 to 7. Whoops. And these will be brackets. That's a comma. All right, so as I look at my choices, it is this one. And you can tell the brackets right here as opposed to the parentheses that are here. So in this location, I will put bracket -7, 7. And so it was choice A, and there it is in interval notation. And here is the choice. So on each one of the problems, I'm going to solve the inequality, I'm going to draw the number line graph, and I'm going to have the interval, and then I'll take those and answer the appropriate part of the question. All right, number 2. The absolute value of x minus 3, close absolute value, is less than 8. Because it just has less than, that means that I'll be using parentheses everywhere. All right, how do I solve it? I take the negative, the symbol, what's in the absolute value, another less than, and the 8. What's in the absolute value falls between the negative and the positive. And now we're going to solve this 3-part inequality. We haven't had to solve one till now. You want x by itself, so you're going to add 3, but you're going to add 3 to all the parts. That gives me -5 is less than x, which is less than 11. X is between -5 and 11. And there will be parentheses because it is not including those. As an interval, it will be -5, 11. So as I start to solve this, as I start to answer the questions, this is my work. I have an interval, a number line graph, and this is an inequality, a number line graph, and an interval. If you took Math 307, you practiced this. All right, let's see. From -5 to 11, the only one in the right format is here. And I know I'm doing these out of order. The solution as an interval is -5, 11. We're not writing the inequality, but I used it to generate the other 2 pieces of the answer. Let's look at number 3. Absolute value of x plus 7 is less than 7. This 7 is a -7 over here and a +7 over here. What goes between the symbols is this. and it goes between the negative and the positive. All right, to solve this inequality, I need x by itself in the middle, so I'll subtract 7 from all three parts. That gives me negative 14 is less than x, which is less than 0. There it is as an inequality. I'm not going to be answering with an inequality, but on a number line graph, that means that x is between negative 14 and 0. It's between them, and it's going to have parentheses on both sides. So it's that one right there. To write that solution as an interval, okay, I need the interval. The interval is from negative 14 to 0, parentheses on both, negative 14 to 0. You can see that I get the number line before I write the interval the way I do it, but then I just transfer the answers in the correct order. All right, number 4. I have absolute value of x plus 6 is less than or equal to 11. I cannot use my inequality solution until the absolute value is isolated, so I have to subtract the 6 first. The absolute value of x is less than 5. That means that negative 5 is less than x is less than 5. Whatever is inside here is between the negative and the positive of the constant. So number line, and I'm so sorry, I lost my equal. I'm going to have between negative 5 and 5, it is everything between there. So that looks like this one. As an interval, it is negative 5 to 5 with brackets. So that would go here, bracket, negative 5, comma 5. All right. Okay, we have a couple more. I have the absolute value of 5x minus 5 is less than negative 10. Now let's go back to our statement. Just like it was with equations, with inequalities, it says if a is a positive number. Well, a is not a positive number. The absolute value is isolated, but the absolute value of something, no matter what it is, cannot be less than a negative because it can't be negative. So we stop. Let's see, and I will choose this one because there is no solution, and I will choose this graph because there are no marks on the solution, on the number line. So the constant, when the absolute value is all by itself, cannot be a negative. All right, let's look at this last one. Absolute value, x minus 8 minus 6 less than or equal to negative 2. Now at first you might say, oh, there's a negative, I'll stop. No, the absolute value is not isolated yet. So I need to add 6 to both sides. I have the absolute value of x minus 8 is less than or equal to 4. All right, so now I can use my process. Negative 4 is less than or equal to x minus 8, which is less than or equal to 4. So whatever is here goes in between negative of this and the positive of this. So I need to get x by itself, so I'm going to add 8. I need to do that to all three parts. That gives me 4 less than or equal to x less than or equal to 12. So x is between 4 and 12, and it will have brackets because of the equal to. So x is any of those numbers, and it looks like it would be this one. And as an interval, it will be 4 to 12 with brackets. So that's what we will write up here because it does one interval notation, 4 to 12. Okay, so as a little summary, if you have the absolute value of anything with x is less than a number, that means that you will have negative of the number is less than anything with x, which is less than the positive of that number. So you will always have whatever this is in the middle between, this is the negative of that, and this is the positive of that. You'll need to solve this for x. Okay, I hope you can, this got a little negative. There we go. So it is between the negative and the positive. And that gives you the between notation on the graph, and it gives you intervals from this number, comma, this number once you've solved for x. All right, go take care of those problems.